All right, this is a question that looks like something you might see on the AP Calculus AB exam, where sine and cosine intersect an infinite number of times. Find the area of one of these regions. And of course, we know that the bounding regions of each area are equal. So let's just take a look at what this might look like. First thing I'm going to do is set up a picture here and say, okay, let this be the Cartesian plane, and let me do sine in yellow, and this is just my estimation of what this thing might look like. It might look something like this, and then it's going to keep going and doing its own thing, right? And then cosine in blue would start at 1 and would go like this, and then come up through here and do something like this, and then continue, right? And it would intersect over and over and over again. So what we're saying is, what's the area here? So this is actually not a really difficult question. It's just a question you have to kind of look at with an open mind. So what I would say is this, that I'm going to look at this particular section right here and let this be the origin. So I'm going to look at the section to the right of the nearest to the right of the origin. And I'm going to try to figure out, I'm going to look at this and say, okay, well, when is sine of x equal to cosine of x? And there are tons of ways to do this. One way to do it is that you could subtract cosine from both sides and ask yourself the question, when is sine of x minus cosine of x equal to 0? And then you could try to solve that. Or if you wanted to, you could divide both sides by cosine of x. And if you divided both sides by cosine of x, you would get sine of x over cosine of x is equal to 1. And sine of x over cosine of x is tan of x, and tan of x is equal to 1. And maybe you know that tan of x is equal to 1. The nearest places here and here are at pi fourths and 5 pi fourths. From here, what you want to do is you want to kind of take this into consideration. You want to keep in mind this principle here that says that the area bounded by two curves is represented by the definite integral from a to b of f of x, that is the function on top, minus g of x, that is the function on the bottom on the interval that you're looking at. So if we look at this in this case, we're looking for this a and this b value. Well, it looks like the a value, right, this intersection right here is pi fourths, and this intersection right here is 5 pi fourths. So is pi fourths to 5 pi fourths. And then I'm going to start plugging in what I know about this. So I'm going to say again that the area is equal to the definite integral from pi fourths to 5 pi fourths of f of x. Well, f of x we said was sine of x, right? Because on the interval we're looking at, this yellow curve is sine x, and cosine x is underneath of it, so it's sine x minus cosine x dx formulaically. And then from here, I'm going to start to integrate. So when I integrate this, remember the first integral of sine of x is opposite cosine x, keeping in mind that this negative sign right here is this negative sign right here. When I integrate cosine of x, I get sine of x, right? And then we're just going to use a little bit of notation form here and say that we're going to evaluate this from pi fourths to 5 pi fourths. Then we're going to tell our AP reader that we intend to use the fundamental theorem of calculus. So I would write to that reader, I'm going to use the fundamental theorem of calculus, and I intend to take f of 5 pi fourths minus f of pi fourths to get my area. Now you might make a mistake in the arithmetic here, which is not as important as the fact that you're telling your AP reader, the person grading your exam, what you're doing the whole way. So this notation is going to help you to get the points that you're looking for. Remember, there's 9 possible points here. So I'm going to go ahead and take this. I'm going to plug this in here, and I'm going to get opposite. Well, what is cosine of 5 pi fourths? Well, cosine of 5 pi fourths is negative square root 2 over 2, right? And then I'm supposed to subtract minus, so this minus sign is this one, minus sine of 5 pi fourths, and sine of 5 pi fourths is also negative square root 2 over 2, right? And this gives me my value, these two things together give me my value for f of 5 pi fourths. I'm going to move forward now, and I'm going to subtract f of pi fourths, so this negative sign is here, and I'm going to take out all of this here. So we have opposite. Well, what's the opposite? This negative sign is this one right here. and I want cosine of pi force, and cosine of pi force is positive square root 2 over 2, right? This negative sign right here is this one, and I want sine of pi force, and sine of pi force is square root 2 over 2. Remember, we said that we were going to subtract this whole thing. So this negative sign is subtracting up this whole thing. So take a look at this. This cleans up pretty nicely, I think. Negative times a negative is a positive, so this goes to positive, doesn't it? Negative times a negative is a positive, so it's plus this, isn't it? Negative, I'm going to distribute this negative sign in. So as I distribute this into here, this goes to positive. As I distribute this to here, this goes to positive. This goes away, doesn't it? So what we're going to get here is 1, 2, 3, 4, 4 square roots of 2 over 2, otherwise known as 2 square roots of 2. So look, I hope this is really helpful. The way to do this is to practice a bunch of these problems, to ask questions, to try to find people who have done other examples and see if you can find an algorithm that works really, really well for you. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks. I appreciate it.